How's it going, y'all? Welcome to Rocket Team. This is going to be your first lesson on rocketry or rocket science. Our first lesson is going to be rocket anatomy. I'm Thomas E. Laybourne.
And I'm Severin E. Krautman.
And we're really glad that you're here. This is our agenda for today's lesson. Nomenclature. We'll be discussing the outside nomenclature, or the names of the different components of each rocket. We'll also be discussing the inside nomenclature of the components of a rocket. We'll discuss fin types, nose cone types, and finally we'll conclude with stages of flight. I'll be followed by Mr. Severin Krautman in discussing the outside nomenclature of a rocket.
So, when you look at a rocket on the outside, it starts with your nose cone, working from the top down. Just beneath the nose cone are the critical parts that build up the structure of the rocket, the body tubes. In our case, we have two body tubes, a forward and a rear body tube. On the outside of the rear body tube is a piece called the launch lugs. The launch lug is what controls the rocket as it launches from its launch pin or out of its launch rail. We use a rail system. On the very back side of it, and very importantly controls the guidance of the rocket, is the fin types. Over here, we have all of the interior nomenclature for the rocket. So again, starting at the top, we have the nose cone sits on top of our cargo bay. Inside of the cargo bay is the altimeter. Beneath that is the coupler, which has the forward bulkhead underneath of it. The forward bulkhead has a shock cord attached to the forward bulkhead that is tied through a loop, as well as tied through to the shroud lines for our parachute or some other type of recovery system. We use parachutes. That same shock cord tracks all the way down through the rear body tube and is attached through the forward centering ring and to the rearward centering ring. The centering rings hold our motor tube in position, and the motor tube has an engine hook and an engine block attached to it. That engine hook is what holds the motor in place while the ejection charge separates the forward tube from the rearward tube. The entire portion of the motor mounting section is just called the motor mount. It has your forward centering ring, the motor tube, the aft centering ring, as well as your engine hook and motor block. I will be followed by Mr. Thomas E. Laybourne in discussing fin types and nose cone types.
So while we're building our rockets or designing our rockets, you're going to encounter several different types of fins and nose cones. All of them have advantages. Some of them have more advantage to others, especially when it concerns aerodynamics and the effectiveness of your rocket. Let's first start with talking about fins. Fins get progressively more aerodynamic. Some fins will start off as what is called rectangular, and that's just a rectangle sticking on the side of your rocket. Those are very simple to make, but they are not very aerodynamic. They progressively get more sleek or elegant looking with triangular shaped fins, clip to delta, which is the type which we have often been using with our rockets, swept to delta, which you'll see on many of your commercially made rockets, or even elliptical, which is your most advantageous design. We have actually used a combination of these different designs in a 3D printed type of fin, which is trapezoidal, which combines both clip delta, swept delta, and triangular fins, which is very, very effective as it very much models the same performance of an elliptical fin without the complexity of building. As far as our nose cones similarly can be more aerodynamic or less aerodynamic, and this shouldn't be a surprise to anyone. The least effective aerodynamic structure for a nose cone is going to be just a big old square or a cylinder shape, which is so flat. This causes the air flowing around it to be very, very choppy and turbulent, and it is not very good for rocket performance. As you get progressively more aerodynamic and more sleek looking, like a bullet shape, you're going to have better performance. The worst are going to be rectangular or kind of like a an Aztec temple, to conical, to something called a teardrop, to even the most productive, which is going to be an ogive. We have actually not gone with the ogive, which is your traditional rocket cone shape, but actually more of a teardrop shape. And there's a couple reasons for that. One is we have them, and we have some which are made out of foam, which is very good for receiving impact. It's also pretty darn good as far as aerodynamics. So these are your better performers. These are your least or your worser performing shapes for nose cones. At this point, I'll be followed by Mr. Severin Krautman, who will discuss stages of flight.
So over here, as we look at our first stage of flight, we call it our launch stage. And just before launch, we call it ignition. That's where your rocket engine actually ignites through an electronic system. As it moves through launch, we get to stage 2, engine burnout. This is where the thrust of the engine is actually lifting the rocket, and once we pass stage 2, we move into stage 3, coasting. So the rocket still has energy that it is dissipating as it coasts farther up, gaining altitude, and as it noses over and reaches stage 4 at apogee, this is the point at which the rocket is essentially weightless, and if it's possible, the most ideal point for the ejection charge of the engine to separate either the body tubes or the nose cone and deploy its parachute. We call that stage ejection. Once the parachute has caught its load, it is full of air, fully inflated, and it settles down to the ground. The final stage of flight is when the rocket actually hits the ground, the parachute collapses, everything's on the ground, and we're able to move into recovery. Once we get to recovery, that's where the exciting part is, where we get to go back and check our data and see just how well our rocket performed.
This concludes our very quick lesson on nomenclature, stages of flight, and fin types and nose cone types for your first experience with learning about model rocketry, and so we can actually have our rocket class. Make sure that you are taking good notes. Good note taking is absolutely essential for any sort of class or any sort of professional experience, but especially with this as well. Ensure that you're copying down any drawings or professional drawings that we have, and your penmanship is extraordinarily important. It must be legible. You have to be able to read it. One option you may have, and we encourage you a great deal, is to write all your letters out in capitals. It makes it much easier to read than your script or lowercase letters. It is a technique that engineers have been using for centuries, and it's a good technique. Get in the habit of doing that, and also make sure you put a date on the page when you actually write that stuff down. You can put your own comments down in the margins of your notes, and those are things that you're kind of telling yourself when you're reading down the information from the lesson. Sir?
My last tidbit for you would be to make sure that when you're building the rockets that we've sent home with you already, your small kits, make certain that you're actually using the terminology or vocabulary that we've discussed with you about what these rocket parts are. By using that terminology while you pick up to build your rocket, you will reinforce that information and solidify it into the way that you speak about and communicate about the rockets that we're building. It's very important that we'll be able to communicate specifically and accurately, because as we get more and more into Rocket Club, we're going to try and get smoother, more accurate, faster, and we can't afford to make silly mistakes because we're talking about thingamabobs instead of fins, thingamabobs instead of launch loads. So be sure that you're using the vocabulary to reinforce the knowledge being built into your brains.
This concludes your first lesson in Rocket Team. Ad Astra. Tico's badass.
That was good. Our total time on that too, good.